Okay, these notes are for Calculus A. We are still learning derivatives. However, we are moving out of Chapter 4 momentarily. We're going to jump around the book a little bit. We're going to learn the derivatives of many different functions all at once. And so here we're going to be in Chapter 8, Section 8.1. We're learning the derivatives of some exponential functions. Remember, an exponential function is of the form y equals a times b to the x. But the exponent is where the variable is. So f of x looks like some, and you don't have to have an a necessarily, but you have a base and then you have an exponent power. And so the inside, the x part is actually at the top. It's the exponent because that's where the variable is. All right, we have two formulas. It's really just one formula, but then we talk about the special case of e to the x. And so your first formula here says that the derivative of a to the x is a to the x times the natural log of a. So for example, an a can be any base. If y equals 3 to the x, then y prime would be, according to the formula, 3 to the x, the derivative is 3 to the x times the natural log of 3. And so that's a new formula. That's just a new derivative formula. And the second formula, which is really not a new formula, we're pointing out that if the base is e, so your function is e to the x, then according to the derivative formula, the derivative of e to the x would be e to the x times the natural log of e, but the natural log of e is 1. And so that's just e to the x. All right. For example, we have 4 different functions here that we're going to differentiate, and they all have exponentials in them. In number 1 here, f of x equals e to the 2x squared minus 1. All right, when I take the derivative of that, my derivative formula for e to the x just says that the derivative is the same exact thing. And so that's the derivative of e to the 2x squared minus 1. Very, very simple. Except that you just learned the chain rule. And the chain rule says that if you have some sort of function instead of x on your inside, and remember I just pointed out that the inside is the exponent in exponentials, that's why they're called exponentials, then you need to multiply by the derivative of that. And so we would multiply this by 4x because this is the chain rule. And your inside is the exponent. All right. And so the derivative in terms of a chain rule formula, let's go back up here. The derivative in terms of a chain rule formula would be that the derivative of a to the f of x, maybe, is a to the f of x times the natural log of a times f prime of x, because that would be your chain rule. Okay, it's after school. Very loud in here. So that's number 1. Let's talk about number 2 here. On number 2, I have a product. F is 3 to the x, that's the first part. G would be radical x, that's our second part. I can find f prime and g prime. G prime is just 1/2 x to the negative 1/2. F prime, this is where I'm using my new derivative formula. F prime is 3 to the x times the natural log of 3, because that's the new formula. And now I'm going to use my product rule formula, which is that I take turns doing the derivative. So I have f prime g plus f g prime. And so my answer is 3 to the x times the natural log of 3 times square root of x plus 3 to the x times 1/2 radical x, because that's how g prime simplifies. All right, 2 more examples here. Number 3. Here I have 4 times e to the square root of 3x minus 2. So I'm going to take the derivative of this. Now this is a product, 4 times e to a radical. However, my product, the 4 is a constant multiple, and I don't have to use the product rule for constant multiples. You just get to keep the multiple in the front. And now I'll do the derivative of e to the square root of 3x minus 2. The derivative formula tells me that it's the same exact thing. However, I also multiply by the derivative of the inside, which is the top here. And so if I have a square root of 3x minus 2, that's 3x minus 2 to the 1/2. And so I do 1/2 to the negative 1/2, keeping my inside to the same. And now look at your inside. It was a 3x minus 2, 3x minus 2. So I need to multiply by 3. This was a double chain rule. I will simplify this just a little bit to 6e to the square root of 3x minus 2 divided by square root of 3x minus 2. Okay. Last example on this page, looks like I'm going to be using the quotient rule here. Okay, so I do have a quotient. My top is e to the t to the 4th minus 1, and my bottom is t to the 5 minus 2t. Is that what that says? Okay, so hold on. This is a bad example. Let me change this. Let's change this to t to the 5. Let's just change that to t to the 5th. There's a way of doing derivatives where you have an variable in the bottom and the top, but it's very complicated and not something that you could do in this problem here. Okay, so new question. E to the t to the 4th minus 1 over t to the 5th. So f is my top. F prime would be e to the t to the 4th minus 1 times the derivative of the top, 4t cubed. And then my bottom derivative is 5t to the 4th. And so now I'm just going to use my quotient rule. The function was called s. So s prime is, according to the quotient rule, f prime g minus f g prime over g squared. So that would be e to the t to the 4th minus 1 times 4t cubed times t to the 5th minus e to the t to the 4th minus 1 times g prime 5t to the 4th, all divided by bottom squared, t to the 5th squared. And I'm going to just clean this up a little bit. Multiply together some like terms. Or in this first part, I have 4t to the 3rd times t to the 5th is t to the 8th, collecting t's there. And then e to the t to the 4th minus 1 minus e to the t to the 4th minus 1 minus 5t to the 4th e to the t to the 4th minus 1. So I was at minus 5t to the 4th e to the t to the 4th minus 1 over, and now when you have t to the 5th squared, that's t to the 10th. And now I am going to do something else because I think this is what the back of the book will do and what you'll expect it to simplify to on multiple choice tests. I will factor out common factors. So a 4 and a 5, there's nothing common there, but I do have t to the 8th and t to the 4th, so I can factor out a t to the 4th. And I have e to the t to the 4th minus 1 in both terms. And so I'm going to factor out t to the 4th, e to the t to the 4th minus 1, and then I have left 4 t to the 4th minus 5 over t to the 10th. Oh, well, these cancel. 6. Promise, the last line. E to the t to the 4th minus 1, 4t to the 4th minus 5, all divided by t to the 6th. Okay. That was, those were 4 example problems. I have one more example problem, and it is to find the second derivative of this lovely function. So we're going to start with the first derivative, but I need to do the quotient rule. So before I start with the derivative, let's label the top as e to the x plus e to the negative x, and the bottom as x squared. My derivative of the top, the derivative of e to the x is e to the x, and the derivative of e to the negative x is negative e to the e to the negative x, and then I multiply by negative 1 for the chain rule. And so that's just e to the x minus e to the negative x. And now for g prime, that's simply 2x. And let's do the quotient rule. This is called f of x. So f prime of x would be f prime g minus fg prime with a g squared. So that is e to the x minus e to the negative x times x squared minus e to the x plus e to the negative x times 2x, all divided by x to the fourth. All right, and then your task is going to be to simplify this and then find the second derivative. So you'll have to use the quotient rule again.